So these cluster galaxies, the white ones, we're seeing as they looked about the time the sun and the earth formed. And then behind the cluster, we have the gravity of the cluster is distorting and warping our view of what's behind. And so there are these galaxies that look stretched and pulled, kind of like they've been magnified because they've been magnified by the gravity of the cluster, just like Einstein said they would. And it's really, there's so much detail here. We're seeing these galaxies in a way that we've never been able to see before. There's just a sharpness and a clarity we've never had. Webb got spectra to figure out what those galaxies are made of, and this is that one. We're seeing as it looked 13.1 billion years in the past, less than 1 billion years after the Big Bang, and we're seeing the elements of oxygen and hydrogen as well as neon. This is how the oxygen in our bodies was made in stars, in galaxies, and we're seeing that process get started.
What we did was we observed a transit of an exoplanet. We observed the planet as it passed in front of the star. Now, mind you, this is not a direct image. This is an indirect image. So we've seen the effect of what happens when the planet and its atmosphere passes in front of the star. The starlight filters through the atmosphere, and then you can break that down into wavelengths of light. What you're seeing here is a telltale signature, the chemical fingerprint of water vapor in these atmospheres, in the atmosphere of this specific exoplanet. And the other thing we can tell actually is that there's evidence of clouds and hazes because the water features are not quite as large as we predicted. So we can take that and infer that there are presence of clouds and hazes.